Hi, everybody. I'm Kathy Lord. I think I know practically everybody in the room, but it is my great pleasure to introduce today Summer Bishop. And Summer is an associate professor at UCSF. She did her training at Michigan. She is a complete Go Blue fan, and then went on to do a postdoc with Marcia Malik in Madison, and then went to Cincinnati Children's. Then I managed to convince her to come to New York for a little bit, and then UCSF wooed her back to the West Coast, and I followed her here. Summer is one of the most creative researchers I've ever known, and also one of the absolute best clinicians. And she's managed to put these things together to try to move us in different directions. And she has all kinds of credentials in terms of being on editorial boards and serving on various panels. And I think is stepping up to be really, the next generation of people helping us figure out phenotype and how to describe the kids and adults that we work with. So I think she is going to tell us a lot, and I'm thrilled that she's here. So welcome, Summer.
Thank you. Thank you so much for having me. I am really excited to be here. It's my first time at UCLA, and I got to stay in the UCLA hotel, and the bathrobes have UCLA embroidered on them, and I have a Bruins cookbook in my room, so I'm getting the whole UCLA experience. And so thank you for having me. So I need to start by telling you that I'm an author on the ADOS-2, and I receive royalties from sales of the manual and the protocols for modules 1 through 4, and all royalties related to my own research, clinical work, or training are donated to charity. So I'm going to talk to you today about social communication, and my wonderful mentor told me that when you give grand rounds you should just show lots of videos because that's what people want to do at 8 o'clock in the morning. So I'll show you a lot of videos and show you some new data too that nobody has ever seen before. So RDoC defines the social communication construct as a dynamic process that includes both receptive and productive aspects used for exchange of socially relevant information. Social communication is essential for the integration and maintenance of the individual in the social environment. This construct is reciprocal and interactive, and social communication abilities may appear very early in life. Social communication is distinguishable from other cognitive systems in that it particularly involves interactions with conspecifics. And so I know conspecifics, we usually think of mice, but they can be babies and humans too. And it really is special in that we are defining this in relation to other people and interactions with other people. So I'm going to show you a couple of my favorite conspecifics. This is my daughter, my older daughter, when she was 6 weeks old. And then here she is when she's even better at it. 3 months. And then here is when she's grown up and the new baby was 7 weeks old, and with the second one, the parents don't matter at all anymore. It's just the big sister. So here they are together. That's my big sister. So she did it. So, oh, and here's the little one now. She's 2, and this is my wife, and this is like the best definition of imitates facial expressions. This was all in 15 seconds at a brewery. I tried to hide the beer, but I couldn't. And so here she is just in a roll, taking pictures, selfies. And so, of course, my children are brilliant, but it turns out that most babies attain these skills with very little difficulty. This is from the mother and child birth cohort, so a population-based sample in Norway. And you can see that by 18 months, all of these skills are there for most babies. And then a very small group attained them between 19 and 36 months. And then a really teeny tiny group was reported to not have some of these kind of harder basic social communication skills by 36 months. And even when we're talking about severe neurodevelopmental disruption, really profound intellectual disability, this is a little girl with Rett syndrome. She's 3.5 years old, but she has a cognitive level of about 4 to 6 months. And here she is. She came from Turkey, so they're speaking Turkish, but you don't need to understand the language to see this.
Let's try one more time and then you want to blow it?
Aşk.
Low, you might be a little. What's the ball? That's okay. That's okay. Wanna blow? Mommy's gonna do something. How about you blow one more time and then wait and see if she makes that sound again.
So again, I mean, this is a little girl who is profoundly disabled, but she knows that she can look at her mother and make her kind of needs known and have a connection with her parents. And so one of the reasons why we think so much about social communication in autism spectrum disorders is because when these skills aren't present, especially by a certain age, it really is strongly indicative of ASD or another developmental disorder. And so this is Audrey Thurm's graph and tracking kids who are typically developing with other developmental delays besides autism or kids with autism. And there are two groups here too, one who showed kind of a decline in skills and then one who didn't, but who was on a lower trajectory to begin with. And so these skills really do indicate something. The lack of these skills indicates that something has gone awry, and often it signifies an ASD. And this is one more graph I wanted to show you from the MOBA, because I think it's really striking. So we were able to, with Alex Havdal, who I'll show you a picture of in a second, she is a researcher in Norway, and we were able to look at prospective loss. So in MOBA, they asked questions about attainment of that list of skills that I showed you before, and when the children were 6 months and 12 months and 18 months, and then when the parent reported one being present at the previous visit, but then not present at the subsequent visit, then that was recorded as prospective loss. And here are the odds ratio in terms of predicting the kids who went on to receive an ASD diagnosis. And when there's a loss of these skills, the odds of receiving a diagnosis of ASD are quite high. So I think from a measurement standpoint, because of the significance of social communication abilities and social communication deficits in particular to ASD, our field has come to sort of own social communication, which is good in the sense that we think a lot about it, but our focus has been on identifying deficits in this area. And so here's the DSM. It's clearly prominent. It is the essence of autism, deficits in social communication. But with our measure development, a primary goal has been to classify participants or patients as having ASD or not, so really a focus on between group accurate classification, and less attention given to quantifying severity of impairment or in measuring change within the individual. Everybody wants to measure change, but again, it's coming from this place of how can we measure changes in deficits, which is a harder, to get less severe, less deficient at something is a hard task, or a hard task to measure. So, so when we have then these instruments that measure social communication, and people want to evaluate it in other populations, we have our ASD diagnostic and screening measures being applied to a lot of different groups, and groups for whom they weren't necessarily designed in the first place. So I've thought a lot about this, and this is Alex, and these are analyses that we did a few years ago that I just want to show you quickly. to indicate here, this is our sample. So we had a pretty large group of kids with non-ASD diagnoses that included intellectual disability, language disorders, ADHD, and other kind of neurodevelopmental and psychiatric disorders. We had some kids with mood disorders in here too. And we wanted to see what happens if we look at widely used ASD screening and diagnostic instruments and kind of parse the sample by who has intellectual disability or not, and what does it do to our specificity. And so it really affects the specificity, particularly of the parent report instruments in this case. So the SRS, using the moderate cutoff in the kids with intellectual disability, had a specificity of 27.27. So 73% of kids who had intellectual disability who did not have autism met at least the moderate cutoffs on the SRS. But in fairness, in the SRS manual, it says that nobody in the validation sample had an IQ below 70. And so you think about that, I mean, that's a problem given populations in which it's trying to measure autism symptoms, but we've taken this measure and used it in samples with IQs far below 70 and can't really expect it to work in the same way as it is reported to do so in the manual. And then the ADI, which is a parent interview, we see a decrease in specificity as well. And then the ADAS, relatively similar across ID and not in this group, although we didn't have a lot of kids with really profound intellectual disability. Mostly they had mild. And then the same story for emotional behavioral problems, which Alex has been very interested in, understanding how the presence of non-ASD specific behavior problems can affect measurement. And so parent-reported behavior problems on the CBCL and directly observed behavior problems on the ADAS-E codes affects specificity of all of the instruments. And so basically, if you have a lot of behavior problems and you don't have autism, you're at higher risk for receiving elevated scores on measures of autism symptoms and measures of social communication impairment, which is not surprising, but it's a problem when we're exploring these symptoms in a very continuous way across groups that differ in other important ways. So because IQ and behavior problems are similarly associated with scores in kids with ASD and without ASD, you could imagine having different cutoffs. So having a cutoff for a kid with intellectual disability that's different for a kid with average IQ. And that could increase our diagnostic or our classification accuracy using the instruments. But when we're trying to put together big samples and look continuously at these behavioral dimensions, it gets a lot more complicated to do so. So here, just as an example, here's the SRS, and this is really, Vanessa Ball had shown this before. But we have kids with low behavior problems and high behavior problems, and the red group is the kids with ASD, and the blue group is the kids with other disorders. And there is no difference between the kids with ASD with low behavioral problems and the kids without the kids without ASD, yes, the kids with ASD who have low behavioral problems and the kids without ASD who have high behavioral problems, they look the same. So if you were saying, how's this kid's autism symptoms compared to this kid's, they look identical even though one has autism and the other doesn't. So it's something to worry about. And so we've tried to get down to maybe there are subdimensions within social communication that can help us improve measurement precision. And so again, work with Alex and Kathy and Maricela Huerta, and looking at just the ADAS Module 3, which is for kids with fluent language abilities, so kids who have complex sentences, and our sample was mostly school age here. We see that we do get two factors. One, a basic social communication factor, we called it, which involves things like eye contact and facial expressions and shared enjoyment, all the things that the babies were doing in the first videos, so they emerge very early in development. And then something that we called interaction quality, which can involve the use of these basic skills, but is higher level and can be affected for a lot of different reasons. And so, so indeed, when we look at kind of the variables that are associated with scores on basic social communication versus interaction quality, we find that the only thing that's really predicting the basic scores is having ASD or not. Whereas for kids, interaction quality is affected by nonverbal IQ and behavior problems. So quite consistent with the other analyses that I showed you. And this is just a cute video. This is poor Kate Gotham, and she's been working with this kid. She's on about hour number 3, and he is so active, and she looks exhausted, but he's adorable. But not easy. Okay.
What kinds of things do you like doing that make you feel happy and cheerful? Hey Jared, what makes you feel happy? Yeah, that's what happy looks like. What makes you feel happy? What kind of stuff?
Happiness. Watch this.
Oh, you know what I don't want you to do? Hey, I don't want you to do any jumping on the chairs.
I was trying to reach over so I can get onto this chair.
Jared, when I have my cat with me and my cat is purring, then that makes me happy. What kind of things make you happy?
My mom tickles me and walks me.
Oh.
With the brush.
Oh, that sounds fun. How does it feel inside when you're happy? How does it feel on the inside?
Sad. Spearfish with this.
Hey Jared, what kinds of things, what about things you're afraid of? What kind of things make you feel afraid?
In the darkness, my mom says go forward out of the way. Go forward out of the way.
Yeah, darkness makes lots of kids feel scared. What does it feel like when you're scared? What does it feel like inside when you're scared?
Brave.
Brave? What kind of things make you feel angry? Yeah. What makes you feel angry? What happens to make you feel angry? You don't have to show me. I want you to tell me what kind of stuff happens in your life that makes you feel angry.
Angry means not be nice.
Okay.
I can make you.
Okay, so then he proceeds to go on to try to jump from the one chair to the other chair. So he's got a lot of really nice social communication skills, but the interaction, you could imagine how it's affected by when he's kind of invading her space a little bit. And I mean, he's only 4, he's just a little kid. But if we were thinking about how he might behave in different kinds of situations and his scores on instruments, you could imagine how some of these higher order aspects of social communication could be affected. So the point is that the meaning of any measured behavior depends on the individual in whom it is observed. And so basic social communication skills really do seem to be more specific. The problem is that people get better at them, and everybody gets better at them. So when we're thinking about sensitivity of tools, especially for kids who are older, more verbal, have higher IQ, we can't just hang our hat on those very basic infant level social communication skills, or we'll miss too many. So we've moved to interaction quality, which is important to look at, but it's also impaired for many younger groups and for kids with intellectual disabilities, regardless of their diagnosis of ASD. So we need to keep working on this, but at least it's a start. And I've continued, and this is brand new, like as of yesterday. So I wish, this is Aaron Kott and Shuting Zhang, and Aaron is at Northwestern. He's a wonderful psychometrician, and Shuting is a postdoc with me at UCSF, and this is way beyond my capabilities, what they are doing, but they wrote it all so that if you asked any questions, I could just point to the slide. So what we've done is I've been really interested in, could we get factors if we look across instruments? And the problem is that you tend to get measure factors. So you get a parent report factor and a direct observation factor, or you even get instrument-specific ones. But Erin knew how to trick the exploratory factor analysis into thinking that it's doing a confirmatory factor analysis by pre-assigning items that you really think are going to go together on factors and then seeing where the other ones go. And so we have a training data set that includes 751 kids, and then we're going to test it out. I don't have the test data set results for you because we haven't done it yet, but I thought I would just give you a sneak peek because it looks like we might have additional dimensions. This is just the demographics of the 751 in the training data set, and we focused again on module 3 and kids 4 to 10 just because of the restrictions around the items on the instruments. So some items are only given to kids who are verbal and kids who are of a certain age. So just for the first pass, we really had to hone in on a specific group. I think this also highlights the wonderful power of collaboration when all your friends are willing to share data with you, because since we have 10,000 kids that we're starting with, we can afford to stratify by age and IQ and language level to get at some of this. So thank you to everyone in this room who has been sharing, and we're happy to share as well. So here is what we get. We get 4 factors, and I'm going to show you them one at a time. And there are some items that seem to have loadings across factors, and it's not clear how stable this structure is, but it kind of makes sense so far. So the first group of behaviors was things that really involve modification of behavior appropriate to the social context. So one of these interaction quality kind of factors, but primarily with adults. And you'll see a lot of ADOS items here. So the interaction with an unfamiliar adult, and what is the quality of the conversation and of the social interaction. And then we get something similar, but it's really peer focused. So in these different, in peer situations, how is the child able to modify their behavior? So has difficulty relating to peers, plays appropriately, has difficulty making friends, and then a conversation again here, and social disinhibition. And then this factor is really, all of these items have to do with joining in social interaction, so you could kind of think of it as a social motivation group of behaviors, but to get zeros on any one of these behaviors, it takes, or on any one of these items, it requires that the person is initiating on their own. So they have to join into groups, or go up to children, or initiate basic social back and forth games like peekaboo with parents, and then a couple SRS items, again, peer focused. And then here's the big giant group of basic social skills and emotional understanding, but across measures. So shared enjoyment, facial expressions, all of the big ticket items when we're thinking about what kids with ASD have such a hard time with. So stay tuned. Next time I'll have more, but it's exciting to think that we might be able to drill down into separate dimensions, and we're limited right now by the measures that we have, which are really symptom focused, deficit focused. We try to put the Vineland into these analyses, but because of the Vineland, Basel, and Sealing rules, not everybody gets all the items, and so it's really, so you can't. We haven't. Well, if you guys have any ideas, tell me, because we're trying to figure out how to integrate the Vineland, which is more ability focused, with these deficit-based measures. So where I think that that the specific dimensions of social communication ability or difficulty can be really helpful to us is in some of the work that people are doing on ASD and genetic syndromes, and a lot of people here in this room have been very interested in this for good reason, because if we can have groups that have at least a defined etiology or a presumed known etiology, then we might learn something about mechanisms that are contributing to the manifestation of ASD phenotypes. And so, again, because of the corner on the market that we've had on social communication measure development, high-quality social communication measure development, these instruments have been applied to kids with known genetic syndromes. And But this is complicated because many of the kids who have rare syndromes have profiles that are pretty different from kids with idiopathic or traditionally defined ASD. So identifying suitable matches for them can be really difficult when you're trying to compare an idiopathic ASD group to a group of kids with a rare syndrome. And I think, you know, and then trying to make comments about social communication skills in whatever group you're talking about. And the thing is that for most kids, this just happens. It happens miraculously and everything happens at once. And people end up pretty much able to do everything and it's all okay. And so there's a huge developmental literature about social development and communication development, but that's been largely separate from a lot of what we've been doing in ASD. And in terms of tracking the timing of, you know, what skills come first and what relies on what, we haven't done that in so much of a refined way, partially because they either happen for kids altogether or they don't happen. And so this is something that I'd like to, Shefali and I just had a long conversation, so we're going to do something about this. But to understand really the similarities and differences between specific groups, we have to map profiles and consider the skills in relation to other skills, and mapping profiles over time is really critical, but longitudinal data are of course hard to come by. So one of the things I want to show you now is just what this looks like. And oopsie, I don't know why that's happening. So this is a little boy with, who's 5 years old, and he has a nonverbal mental age of 20 months as measured at 5. So he's got an estimated ratio IQ of about 32. So really quite low. He's nonverbal. And here he is with Becca.
Today is baby's birthday. It's baby's birthday. Let's make a cake for baby. Let's make a cake.
So one of the things that strikes me about him, so this is a boy who has a diagnosis of autism, his etiology, he does not have a known genetic etiology, but look at how awesome his motor skills are. I mean, he's able to flip that plate so beautifully, and really, I mean, for an IQ of 30, when you're thinking about other kids with an IQ of 30, that's just interesting to me that his repetitive behaviors are really, his motor behaviors in the context of him being so repetitious with that plate are so intact. And so we were able to use the Simon Simplex collection to try to look at this in a larger group of kids. And so from the whole collection, selected a group of kids who had high confidence, as Stefan says, Stefan Sanders, de novo loss of function or de novo CNVs in or including a high confidence ASD gene. By the way, this is a moving target. There are now more than 112, but at the time we had 112 kids. And then matched them on sex, age, and nonverbal IQ to a group of kids from the Simon Simplex collection who had no evidence of one of these mutations. A huge limitation of this analysis, I'll tell you just right now, is that those 112 kids represented many, many different genes, and we had to lump them all together to get any kind of power, but again, it's a start. So you can see that the matched autism controls and the high confidence group were really closely matched in terms of age and then nonverbal IQ, still pretty darn high, IQs of 75 or 74, but big standard deviations, and quite a bit lower than the rest of the Simon's collection as a whole, which is the reference group. So what we wanted to see is if we matched kids like this, whether we could get differences in profiles. And previous analyses had basically found that if you had one of these rare mutations, that you just looked worse on everything. You looked more autistic, you had lower IQ, you had worse motor skills, and but thinking about the fact that those variables can really affect scores on the autism symptom instruments, we wanted to control for that by matching. And the big peak here is that the kids with the rare mutations walk a lot later than the kids who don't have them. And then we also get some peaks here in terms of parent-reported social communication on the ADI. And then what I think is really interesting is diagnostic certainty. So the kids who had the de novo mutations, and the clinicians were blind to this because the genetic results didn't come out until several years after we'd collected the phenotype data. But the kids who had the rare mutations, the clinicians were less certain about the autism diagnosis than the kids who didn't, which I think is another clue. So here's motor skills. You can see age of walking, and this is just to show you age of walking because it's really striking. The kids in the green are the children with the de novo mutations, and some of them are not walking until over 30 months, and that's just not happening so much in the children who don't have evidence of these kinds of mutations. Language tended to be a little bit higher in the children with the de novo mutations compared to the children without. And then ASD symptoms and diagnostic certainty, as I mentioned, also tended to be lower in the kids with the de novo mutations compared to the kids without. So, but these kinds of differences were only apparent when we compared to relevant controls. So if you put everybody together, the children with the rare genetic mutations look like they've just had a bigger hit all around, and they look worse on everything. So what I think is cool about this too, though, is that attending to the paradoxical aspects of ASD could really shed light on pathophysiology of ASD-related phenotypes. And so this was a follow-up analysis to something that we'd done a couple years before on age of walking, where we found that, so I noticed that when I was in clinic and a kid came in, so in the study that I showed you where we collected all the children without autism, we made ourselves be blind to the previous diagnosis that they had. So the person conducting the parent interview and doing the child assessment had no idea who was coming in through the door because we wanted to make sure that our instrument ratings were blind to this knowledge that might affect our ratings. So, but what I noticed is that when I had kids coming in and I was doing the ADI with their parents and the parents were telling me that the child didn't walk until 24 months, I immediately thought, oh, they must be a control. And so that made me think, well, why am I thinking that? And indeed, if you look at children with autism in a clinical sample, what you see is that they mostly do walk on time, or the vast majority do. So we looked in Kathy's big data set from multiple clinical research centers to see if you look at IQ, in children who receive a clinical diagnosis of ASD compared to those with a non-ASD developmental disorder, mostly intellectual disability in these upper groups. And for this analysis, we took out the kids who had known syndromes like Down syndrome, but we didn't have genetic testing results on all of them. So there are probably some kids with the rare mutations who are mixed in here. But you see that you're much more likely to walk on time if you have ASD and an IQ of 30 than if you have something else and an IQ of 30. And we were worried, though, that this could really reflect ascertainment bias because when kids aren't walking, they don't often come to psychology first. So, if you've got a 2-year-old, they go hopefully to neurology and genetics before they end up in the specialty autism clinic if they're not walking. So here with Alex and Audrey and Kristen Farmer and other colleagues, we wanted to look in the epidemiologically ascertained sample from Norway. And so here you see the same pattern, which is that These are IQ bands. So the blue is an IQ of held constant at 55 versus 70 versus 85 versus 100. And in the kids who have a diagnosis, who end up with a diagnosis of ASD, the rates of late walking are a lot lower than in the kids who end up with other neurodevelopmental disorders, even at the low levels of IQ. So, and this is just to show you that basically the only way that you can have moderate to profound intellectual disability and walk on time is to have autism. I mean, it's really very unlikely to not have, to have that profile. And so this is our theory right here, which is that a lot of kids with ASD start out, they hit early developmental milestones on time, and then the autism gets in the way of learning, and they end up with intellectual disability. Many kids end up not with intellectual disability, and then there's this other group of children who start out delayed in things like walking, and they are maybe the more kind of predestined group to end up with intellectual disability. So at the end of the day, they look similar in terms of IQ, but they started out on really different paths. And this is consistent with the early intervention literature showing that we can improve IQ in kids with ASD. And it would be, interesting to look at how the on-time walkers compared to the late walkers in terms of making those kinds of gains in IQ early on. We wanted to see if other variables associated with ID would show the same interaction between group membership, so diagnostic group, and nonverbal IQ, and nothing came out. So gestational age, birth weight, APGAR scores, and then first words and phrases didn't have the same specificity sort of to autism. And I think that with some of the variables like gestational age and birth weight, what's interesting about that is that could have as much to do with the mother as with the baby, but walking is affected by culture and location of birth. One funny thing is that in Norway, the average age of walking is later than in the US, but particularly for the babies who would start walking in the winter because they're in their snowsuits and they cannot walk. That's our hypothesis anyway. But you see a season of birth effect for age of walking. So it's a lesson also for when we're putting together these huge genetic samples across countries and cultures, you can't have a single cutoff. It has to be in the context of where the behavior is occurring. And so there seems to be something special about age of walking. Other people have shown this with in the Simon Simplex collection. This is David Weiner and Elise Robinson's work, and they're just showing odds ratios for the presence of a de novo mutation if you have either delayed walking and or seizures and or intellectual disability. And if you've got all three, your odds are way up there. And then if you add being female into this, it goes way, way up. So it's a lesson for us about when we should be thinking about referring to genetics too. So here we are, and the ASD is it's not a thing. It's like Kathy said in her Lifetime Achievement Award talk that I thought was really important, which is that we've made this up, and we have ASD related impairments, and the reason that we've made them up is because they are real. The impairments are real and worth measuring. It's just what we're going to call it. And how we're going to do that responsibly. And so it's hard to do, but we do need to get away from descriptions of absolute deficits or capacities and understand these social communication abilities relative to developmental expectations. And I think that one of the things we've been trying to do is walk the line between this categorical and dimensional world and applying RDoC and sometimes, but that's not the solution either, because there are groups of kids who really look similar. It's just that we're not precise in our measurement always enough to pick that up with scores, and then people who are using the scores don't always know where the scores came from. And that becomes a problem. But I think especially when it comes to measuring change, what's really frustrating for clinicians and parents is that kids do make real gains in social communication abilities, and these are not always reflected in currently available measures. And we're getting better at this, but historically, the core symptoms of ASD are typically not the primary outcome for ASD treatment trials, because it's not a good outcome because you don't show changes there like you you do in IQ or language. So I've been thinking a lot about how we might do this differently, and right now I'm working with a group to, this is a parent report measure that we're working on, and Kathy's got the BOSC going for the direct observation, but we all need to work on this together because there's a lot of work to do. And so we've named our measure the Developmental Assessment of Social Communication Abilities. And this was born out of the idea that we could, if we had a preemptive way to match kids to appropriate controls, and then we're comparing their rates of growth in social communication to other kids who are in their same developmental cell, then we could show more incremental changes, either over time or in response to treatment. And this is a skills-based instrument because we're trying to show acquisition of skills rather than reductions of impairment. Eventually it will be computer adaptive, and we're working with Erin and colleagues at Northwestern and to try to make sure that we can have as sophisticated state-of-the-art psychometric methods as possible. We've started doing this, and one of the ways that we started was to collect 1,000 responses from parents of children who just live all over the United States using a company called OP4G. And these are the demographics, and what happened was that 150 of those parents ended up reporting that their kid had a diagnosis of a neurodevelopmental disorder. And we went out to find typically developing kids, and we got 850 of them, but then 150 had autism or another neurodevelopmental disorder. So I've segmented them in the table that you probably can't read. But here are the diagnoses. So language disorder, ASD, ADHD, and then multiple diagnoses or other. And here the idea was, could we identify behaviors that could we get a sense of the timing of acquisition of specific social communication skills? And so we are just starting in here, and this was a quick pass. We're going to go out for another round because some of the items that looked like they were a good idea were a terrible idea, which is why we have to test everything. But this just shows you age by score, and the blue is the kids who don't have any diagnosis, and the red is the kids who do have a diagnosis, and that's a smaller group. But we are seeing for many of these items really clear age effects, which is good because we're trying to pick abilities that emerge in typical development and get a sense of the timing where you could actually put an age equivalent score on social communication ability. And then some of them show really interesting opposite patterns in terms of the kids with diagnoses, but that may be a sampling issue. So these are some of the initiation items, like when your child wants something or wants to show you something, does he take you by the hand or physically lead you there? We also gave parents the option to say this no longer applies, or my kid grew out of this, because we started at age we started with 6-month-olds and went all the way up to 10-year-olds. And it's also interesting to hear what parents think, behaviors that they think their child no longer apply to their child. We point 100 times in a day and to each other, and even though we're not 3, but parents maybe think they don't point anymore. And these are, but if we're getting parent report measures, we better know what parents are thinking about and reporting about reliably, or else it's worthless. And then here are some of the verbal items that we had. And we're at the item level there, and then are going to go back out for another round and then test it in a bunch of really large clinical samples to see if we can identify levels of social communication ability within very narrow developmental cells based on age and IQ. So just to wrap up here, measurement of social communication is affected by multiple factors, and we need to recognize the limitations of current measurement tools and strategies, and be careful when analyzing data. So we're all trying to learn together, but we just need to understand what it is that we're analyzing. And as data sets become publicly available, it's a wonderful resource, but it also can bring dangerous conclusions. And comparison groups, when we're comparing across cross-groups of kids with different kinds of neurodevelopmental disorders need to be selected thoughtfully. And then ultimately, I think using trajectories as phenotypes, I mean, everybody agrees that's the key. It's just a matter of how do we get enough kids and follow them from birth to death, and then actually, you know, get funded to do that, which seems impossible. But identifying phenotypes that are potentially less susceptible to developmental effects, or that are actively accounting for developmental variables in measurement is probably going to be critical for linking behavior to biology. I mean, that's what I think is important about the age of walking. Yes, age of walking is affected by other things, but it seems to be relatively immune compared to some of the other things that we're measuring. The idea that we would look at social communication abilities in a 10-year-old and that would revert back to the specific genes it's a little bit pie in the sky, but everybody's trying. So I think we just have to think about how the kid actually got there and what all went into that so that we can make sense of things. So I just want to acknowledge all my collaborators. Here are the big ones for the slides that I presented, and funding sources, and especially the families who participated in all of this research. So thank you.